Welcome to DBMS course. In this session, we will discuss about how to find additional functional dependencies by using a given set of functional dependencies on a relation. So let us start the session. What are the possible functional dependencies on a given relation? Suppose we have a relation with two attributes a comma b, and we want to find the total number of functional dependencies possible on this relation. Then how to find the total number of functional dependencies possible? So here R is a relation with two attributes. So the attribute set, what is the attribute set for this relation, sir? A comma b. Now, what is a functional dependency? Functional dependency is of the form x implies y, where x is subset of the attribute set. So, x is subset of the attribute set. Similarly, y is the subset of the attribute set. Okay. Now, what are the possible sets for x? Okay. The x can be any one of the subsets of the set a comma b. What are the subsets of a comma b, sir? Empty is a subset of a comma b. I can write singleton set with a is a subset of a comma b. Similarly, we can write b, and then we can write ab. So these are the possible subsets of a comma b. Totally, how many subsets are there, sir? 4. So in the place of x, I can write any one of these 4 sets. Similarly, what about y, sir? The same. It can be a subset of a comma b. So I can write any one of these 4 subsets. So this is. So now the functional dependency is x goes to y. Here x is having 4 possibilities and y is having 4 possibilities. What is the total number of possibilities, sir? By the product rule, the total number of possibilities will be what, sir? 4 into 4, that is equal to 4 square, which is equal to 16. Is that clear, sir? Suppose let us generalize it. Suppose we are having the attribute set with n elements. I have n attributes. We have n attributes. Then what is the total number of functional dependencies possible? Okay. Now x goes to y. For x, how many possibilities will be there, sir? The number of subsets of the attribute set. Here the attribute set contains n elements. So the number of subsets will be how many, sir? It will be 2 power n. Then what about y, sir? This is also having 2 power n. By the product rule, what is the total number, sir? The total number equal to 2 power n into 2 power n. So what is it, sir? 2 power n plus n, which is equal to 2 power 2n. Is that clear, sir? Let us consider one example. Suppose I have a relation a comma b with attributes a comma b with functional dependencies a implies b and b implies a. So the total number of possible functional dependencies is 16. But out of those, how many are valid and how many are doesn't hold on the relation? Now let us try to do it. Okay. So for that, first let us list out the subsets of the attribute set. What are the subsets of the attribute set, sir? Pi, singleton set with A, singleton set with B, and set with A comma B. Now what we do is, for each of these subsets, we find the closure. Then we will write the functional dependencies. First, let us find the closure of empty set. What is the closure of empty set, sir? With empty attributes, we cannot find any attribute. So this is empty only. Let us write it clearly, sir. Okay. So the one and only functional dependency possible is empty implies empty only, because with empty We cannot find any other attribute. Fine. So let us consider the second one. Suppose I am considering the second subset. What is the closure of A, sir? Let us assume this is 1, this is 2. With 1, with A, I can find A, sir. With 1, I can find B. Right, sir? So with A plus, we are able to find 2 attributes. Then what we can write is the set of all functional dependencies will be like this, sir. With A, I can always find empty sets, sir. That is real because the right side is a subset of the left side. With A, I can find A also. With A, I can find B also. With A, I can find AB also. So what we are writing, sir? On the right side, we are writing all the possible subsets of the closure set. Similarly, what is the closure of B plus, sir? So with B, I can find B, sir. By using second functional dependency, we can write A also. So what are the functional dependencies possible, sir? B implies empty set and B implies B. Of course, this is also a trivial functional dependency, sir. With B, we can find A also. With B, we can write AB also. Am I clear, sir? So let us consider the next one. The closure of AB plus. With the help of A, I can find A. With the help of B, I can find B. So what are the functional dependencies, sir? AB implies empty set. AB implies A. AB implies B. AB implies AB. Is that clear, sir? So whenever I want to find the set of all possible functional dependencies from X, then first what we need to do is we find the closure set. Then for the answer, we write all the possible subsets. So all the possible subsets we can write on the right side. So let me explain with one more example. Suppose we are having a relation with 3 attributes A, B, C. With functional dependencies, A goes to B, B goes to C. So what are the subsets of the attribute sets, sir? Empty singleton set with A, singleton set with B, singleton set with C, and set with A comma B, set with A comma C, set with B comma C. Similarly, set with all the 3 elements. Clear, sir? Now what is the first one? Empty set. What is the closure of empty set, sir? Empty. So the one and only functional dependency possible is pi implies pi. Then let us consider the second subset. So we can write simply A, sir. So what is the closure of A? With A, I can find A. By using, let us give numbering. By using 1, I can find B. Now I have B also. By using 2, I can find C also. Right? So to write the functional dependencies, what we can do, sir? A implies, in this place, I can write any subset of the closure of A. I can write any subset of the closure of A. So what we can write, sir? A implies empty set. Empty set is subset of any set. I can write A implies A. We can write A implies B. We can write A implies C. A implies AB. A implies AC. A implies BC. A implies ABC. Because the closure set is equal to A, B, C. Suppose instead of this one, I want to find the closure B plus. Okay. So what is B plus closure, sir? With B, I can find B. With B, I can find C also. So the closure contains only 2 elements. So what are the functional dependencies, sir? With B, B, and on the right side, what you can write? Any subset of B plus, right? So what you can write, sir? B implies B, B implies C, B implies BC, and of course we can write B implies empty also. So like this we can find the set of all possible functional dependencies. Is that clear, sir? Now the next one, the closure of set of functional dependencies. Whenever they given a set of functional dependencies, we can find the closure for that particular set. So what is meant by the closure of the set of functional dependencies? Suppose F is a set of functional dependencies that hold on a relation, then the closure of F is the set of all functional dependencies that can be inferred. So inferred means that can be derived or that can be find from the given functional dependencies. That means they will give some set of functional dependencies and we find the set of all possible functional dependencies. Then that particular set is called closure. For example, in the previous slide, we have seen a relation with three attributes and two functional dependencies, A implies B and B implies C. And if you work out the entire problem, these are the possible functional dependencies for the given problem. So please observe here, sir, this one we have already solved. A implies A implies B, A implies C, A implies AB, A implies AC, A implies BC, A implies ABC. Here I not mentioned A implies empty because we are not deriving any attribute. So that's why I didn't mention it, sir. If you want, you can write it also. Is that clear, sir? Similarly, this one we have verified. BC implies B, BC implies C, BC implies BC. If you want, you can write this one also. Like this, you can verify the remaining also, sir. So the set of all possible functional dependencies by using the given set of functional dependencies is called closure set of that functional dependencies. So let us see one question, sir. Let a relation R with the attributes A, B, C, D, E, F, G, H satisfy the following functional dependencies. A implies B, CH implies A, B implies E, BD implies C, and EG implies H, DE implies F. Which of the following functional dependencies is also guaranteed? Okay, whenever they given the options like this, it is very easy, sir. If you want to find out set of all possible functional dependencies, for every subset we need to find the closure, and for every closure we need to write all the possible functional dependencies. Here it is not needed, sir. So let us solve it. So these are the functional dependencies they given. Let us verify the first option. So what we need to verify, sir, whether BFG implies AE or not. For that, what we do is find the closure of this one. If the closure contains these two attributes, then it will hold. If it doesn't contain these two attributes, it will not hold. Okay. So let us find the closure of BFG. So with B comma F comma G, I can find BFG. Anything else, sir? With B, I can find E. Am I right, sir? Then anything else? Please check it, sir. A we cannot apply. C we don't have. B we already applied. B comma D we don't have. E G, with E comma G I can find H. Fine. Then with D comma E we can find F, but I don't have D. Anything else, sir? So we don't have anything. So the closure contains only these 5 attributes. Here the closure does not contain A comma E. A is missing, sir. A is missing. So this is not holds or does not holds. So this will not be implied by the given set of functional dependencies. So let us try the second option. What is second option, sir? C E G implies A B. So find C E G closure. What is the closure of this one, sir? With CEG, I can find CEG. Now, anything else, sir? Please check it, sir. So with A, we don't have. With the CH, we don't have. With the B, we don't have. BD, we don't have. With the EG, we can find H. Right, sir? So anything else? With the CH, I can find A. Right? With A, I can find B. So we got AB in our closure set. These two values present in the closure set. So this is valid or it will hold on the given relation. So option B is our answer. Is it fine, sir? The next question. In a relation with attributes A, B, C, D, E. So we have 5 attributes. The following set of functional dependencies are given. A implies B, CD implies E, A implies C, B implies D, E implies A. Which of the following functional dependencies is not implied? Please observe this, sir. So out of these 4, 3 will be implied. Only 1 will not be implied. So we need to find which cannot be derived by using the given set of functional dependencies. So these are the functional dependencies, sir. Let us try the options one by one. So option A, CD implies AC. So what we need to do, sir? Find the closure of CD. With the C, I can find C. With the D, I can find D. Anything else, sir? So A we cannot apply, sir. With C comma D, we can find E. Then with E, I can find A. So I got 2 attributes, A comma C. So CD implies AC is valid. So option A is valid, sir. That means it is not our correct answer. So now let us verify option B. Option B is BC implies CD. So what we need to find? We need to find the closure of BC. BC closure, sir. So it contains B comma C. Now with B comma C, what we can find? With B, I can find D. Then anything else, sir? With the C comma D, we can find E. Okay. Then anything else, sir? I think we can stop here because we already got C comma D. Anyway, let me finish it. With the E, we can find A. So with B comma C, we can find all the attributes. We already have C comma D. So BC implies CD holds. What about the next 2 options, sir? Option C, BD implies CD. So let us find the closure of BD. With BD, we can find BD. Anything else, sir? I think with B, we can find only D. With D, it is nothing possible, sir. So the closure contains only these 2. So here C is missing, sir. C is missing. So this functional dependency is not valid or not implied. Is not implied. So this is our correct answer. Is that clear, sir? The next one. Consider the relation with attributes x, y, z, v, w, which satisfies the following functional dependencies. xy goes to z, yz goes to v, zv goes to w, vw goes to x, and xw goes to y. Which of the following functional dependencies is also guaranteed? So one of them is implied or valid. So we need to identify it. The same procedures are for every option. Please find the closure of the left side. So for option A, xz implies y. So this we need to find. What are the functional dependencies, sir? These are the functional dependencies. So let us find the closure of xz. What is the closure of x comma z, sir? I can find x comma z. Anything else? I think we cannot find any other attributes, sir. So the clauser contains only these two. So I think we didn't get V, sir. V is missing in the clauser. So that's why this XZ goes to V is not implied. So option A is not correct. What about option B, sir? Option B is YZV goes to X. So find the clauser of YZV. What is the clauser of YZV, sir? The clauser is YZV. Fine. Then with YZ I can find V. It was already there, sir. With ZV I can find W. But we need X. Okay. With VW we can find X. So we got X. This is implied or it is valid with the given functional dependencies. So this is our correct answer. Is that clear, sir? The next one. Consider the following functional dependencies. AB implies C, C implies D, BD implies E. For a relation with 5 attributes A, B, C, D, which of the following set functionally determine E? Sir, here the same question they given in different format. Which of the following set functionally determine E? That means we need to verify which of these options implied A. So I need to verify whether this holds or not, or I need to verify whether AB implies E holds or not, or the third option is BCD implies E. The last option is CD implies E. Okay, and please observe it, sir. It is a MSQ. So let us try the options. The first option. For this, what we need to do? The clauser of A, C, D plus. With A, C, D, I can find ACD. Anything else, sir? With the C, we can find D. That we already written, sir. With the BD, we can find E, but we don't have B. So the clauser contains only this. So E is not there. So this is not valid. So option A is not correct. What about second option, sir? We need to find the clauser of AB. What is the clauser of AB? With AB, I can find AB. With AB, I can find C. With C, I can find D. With B comma D, I have B comma D. We can find E also. So E we got. I can write AB implies E. So this is valid. What about next one, sir? Clauser of BCD plus. With BCD, we can find BCD. Okay, then with BD, we can find E. So we already got E, sir. We can continue it, but we already got E. So BCD implies E is valid. So this is correct. This is correct. What about last option? Clauser of CD plus. With the C, I can find C. With the D, I can find D. Anything else? No, sir. So here we don't have E. E is not present or E is missing. So this is not valid. So this is also not correct. Only B and C are correct. Is that clear, sir? So this is about finding functional dependencies using a given set of functional dependencies. In the next class, we discuss about how to find or how to determine candidate keys by using a set of functional dependencies. Thank you.